Very good morning, good afternoon, good evening to all the participants, my students and friends. A very warm welcome to this course under NPTEL MOOC, the title of which is Application of Forecasting, Regression and Time Series Models, and my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as all of you are aware that there are basically three main topics. One is first is forecasting, the second one was regression, and the third one is basically time series models. So, today we are going to start the time series analysis, and we will try to cover all the topics relevant to time series analysis, show examples as we did for the first part, which was forecasting, and the second part, which was regression model. This is week number 11 and this is lecture number 51. So, what is the coverage of this lecture? Coverage will be just will give very simple introduction of time series and give some examples without going into solving the problems. As we slowly proceed, we will solve the problems giving very simple examples and using the simple equations as required. Now, why time series is totally different from the concepts of forecasting which we have considered, and also the concept of regression we have considered. So, if we basically differentiate between the first part, which is forecasting, it was basically we want to predict or forecast. I am using the word prediction and forecasting interchangeably. We are going to forecast for the tth time or t plus kth time based on the past data. And here we did pay attention to variability, but not to that extent what we will do now for time series. That is important. Number 2, in the case of say for example, forecasting, the ideas which we or the examples which we considered were related to say for example, rainfall, say for example, the idea of passenger moving in the airline industry for a decade, or say for example, the corresponding facts of what is the production of grains and all these things. But when we come to the concept of time series, we will pay specific attention to financial time series and other time series, because the concept of the variability would become very important. Few very simple concept which I have stated, but I will try to basically draw it in a very simplistic way and then discuss. While the middle topic, which was regression, is totally different from the first and the third. In regression, you have the past data of different type of independent variables x's, and based on that we would basically try to predict or I will not use the word forecast, predict and then find out what would be the value of x we are going to consider. So, what is basically time series? I will draw. Time series is a set of observation and we will consider either denoted by x or denoted by y with a suffix t. And why the suffix t is important? Because it will give you the time frame based on which we are trying to basically draw or delineate the time series information of the data. So, let me continue reading it. A time series is a set of observations x suffix t, each being recorded at a very specific time. Now, this is important. When we are measuring or trying to delineate the time series, let me draw a simple diagram. So, consider you have this y axis where we will denote the value x as we measure, and along the x axis we will denote the time, and here we will denote x t, and when we take the time series we will use the red color. Say for example, the time series is fluctuating like this. It can be stock prices, it can be say for example, GDP, it can be related to say for example, any economic or financial data, whatever it is. It can be in Indian rupee to US dollars rate, it can be gold price, it can be petroleum price. So, whenever you are considering a time series, the time series can be either discrete time series or continuous time series. What we mean by discrete time series is that readings are being taken at some discrete times. Like say for example, I am measuring the stock prices at the end of the day. So, obviously, at end of the day with a gap of 24 hours, if I am considering the end of the day price of the stock, we will basically have the end of the day prices for the stocks, and the time difference between each reading will be 24 hours. It can also be that I am trying to basically find out each after half an hour what is the Indian rupees to dollar rate, then the time difference between each reading would be 1 hour. That would I will consider as the discrete case. Now, when I am considering the continuous case, we will consider that it is being mapped, or we are trying to find out the value of the time series at each instantaneous times. Hence, there is a continuity in the time frame based on which we are taking the reading. Now, the question would be, is it possible to have a continuous time series? In general, discrete time series is the data which you will have, but we will try to basically compensate that and consider the case where the continuous time series modeling will be done in order to understand which type of model it will fit. Now, what are the application? Application of time series can be recognizing the seasonal component. There may be seasonality. Seasonality means the same type of concept which we have considered in forecasting. Seasonality of say for example, price fluctuation of electricity, seasonality of sale of say for example, woolen garments, seasonality of the sale of say for example, coolers. So, the season factor would be there. So, economic statistics such as employment figures are important. We may be interested to find out what is the time series trend and how the values fluctuate. It can also be future values for the series such as sales, population data and all these things. Now, if you remember, when we just started the concept of time series, I did mention the time series concept, or the main focus would be more into the concept of trying to utilize the financial data, because in some way or the other the concept of forecasting which we have already considered does consider different type of examples. If you remember about electricity price fluctuation, which I have given as an example, or which I may have mentioned, it can be say for example, the idea of trying to find out what is the military expenditure for India, or it can be say for example, what is the rainfall and all these things. Now, when the diagram is being drawn, what I have drawn here, there is continuity and there is no gap in the time series which you are measuring. So, hence that it will be considered in a very simplistic sense as a continuous time series data which has been delineated. In case let me use a different color, say for example, the purple one. If I have the data related to discrete and consider the time difference between the discrete time is appreciable. So, what I will have is basically the data for time period 1, time period 2, time period 3, time period 4, time period 5 and so on and so forth. So, any reading in between is not available, but in order to basically mimic the continuous time series data, we will basically join the points which is the top of this histogram, so called histogram, and basically try to compensate utilizing the continuous time series in order to understand the discrete time series and its properties. Now, why the emphasis on time series? If you remember that for any data where time dependence is there, you can have basically 4 types of output. And what are the outputs? I will try to draw one of them each time on this PPT slide and explain accordingly. So, I will erase this. So, I have the time along the x axis, the x t along the y axis, and I may have this type of data. First, I will use the dark red one. So, the time series can be like this. What does it mean? It means two things. Number one, the average value or the trend is fixed, not dependent on time, and if I draw the variability at any point of time, and considering I am considering the distribution per se of the underlying process based on which the time series has been plotted is normal. So, basically I will have a normal distribution with the mean value as the trend value, which is fixed, not dependent on time, number one, and number two, the variability is fixed. That means, the dispersion, if I am looking at the average time or the average trend, the dispersion or the variability is fixed, which means average value, the first moment is fixed, expected value is fixed, and the second moment the variability is also fixed. So, there is the simplest case. Now, if I consider the second case, I will use a different color. Say for example, I use the orange one. Here the time series is like this. I am trying to plot the continuous one. In the discrete case also it will be the same. So, if I plot the continuous case for case 2, here also the mean value would be increasing at a certain rate with respect to the time, but if I consider the variability, interestingly the variability is fixed, which means the first moment or the expected value is increasing at an increasing rate for this example, while the second moment the variability is fixed with respect to time. So, this is the second type of information. Now, till now variability has not changed. So, trying to basically compensate with a fixed increase or a decrease of the average value is we are able to tackle, and we would have definitely considered all these ideas in some details when we are doing the forecasting lectures and we are discussing those ideas. Now, let us do the and compensate the show you the third one. We have discussed that, but still I thought it was relevant for this time series. I will do it, and let me use the third color, which is the green one. Here also a continuous time series, but very interestingly the average value is fixed, but the variability is increasing, which means with respect to time the first moment is not changing for each time period, but the second moment, which is the variability, is expanding, it is basically blowing up. Now, the question can be, can the variability be on a decreasing trend? Yes, it can be very rarely, because generally the concept of variability increase would happen based on time as time goes by, as you move more towards the time calculation and the time graph. So, let us consider the fourth one. So, I will use, say for example, the blue color. Here the average value or the trend is increasing with respect to time, which is the first moment is increasing, and the second moment, which is basically variability, is also increasing with respect to time. So, in the first two there is no problem related to the variability, is only mean in the second case, and it can be handled nicely. In the third and the fourth, the variability is an issue, because in both the cases variability is increasing, and this is where the concept of, if you remember, we have discussed the concept of homogeneity, the concept of heterogeneity, the concept of non-autocorrelation, the concept of autocorrelations would become much more relevant. And if you remember, I kept harping on these points about homogeneity, heterogeneity, heteroscedasticity, homoscedasticity, the concept of autocorrelation, non-autocorrelations would again be repeated in the context of time series. So, having explained this is the main focus, and we will move further on to discuss the type or the way we are able to handle this. So, a time series model for observed data, and the time series model is denoted by x suffix t, is a specification of the joint distribution or possibly of the mean and the covariance. Covariance means the dependence of the data x t with respect to x t minus 1, or with the covariance is basically the relationship of x t with respect to x t plus 1, depending on how the time frame is being measured. So, in this case, if you have heard me correctly, I mentioned x t and x t minus 1, which means I am considering the time difference of 1 unit. 1 unit can be second, can be minute, and whatever it is, that how you consider. So, time series model for the observed data x t is a specification of the joint distribution or possibly the mean and the variance of a sequence of random variables capital X t, for which x t is postulated to be the realization. Realization means before I measure is basically a random variable which is denoted by capital X with the corresponding suffix, and when the value is known to me, I basically denote it as small x with the corresponding t, t means and the time period when I am measuring. What is important is to a complete probabilistic time series model would be given by this, where I am interested to find out the distribution function. So, this is the distribution function which I am talking about. So, I want to find out the distribution function of x 1 being less than x 2, x 1 and x n being less than x n, depending on all the values are less than equal to their realized value what we understand, such that x 1 to x n all the realized values are between minus infinity to plus infinity. For all the joint distribution, the second order properties, the first and the second order moments basically we are talking about. The first moment being related to the mean value or expected value, the second moment being related to the variance. They completely determine the joint distribution and hence give the complete probabilistic characterization of the sequence. So, that means, only having information about the mean and the variance would be enough to give us a good idea about the time series or the data based on which we are trying to basically model the time series. Now, this I am going to consider a very simple example. The data is related to a time series data. I am not because it is proprietary, I am not going to discuss about what the data is, but the actual data based on the normalization I have plotted it, and it will give you a excellent idea that how the time series where you are measuring the time along the x axis. I am not going to basically, this can be weeks, months, whatever it is, and along the y axis I am basically measuring the value of x t. Now, see where the relationship and how the variability is a factor. Point 1, this is definitely not a case or an example where the mean value is fixed with respect to time. No, it is not there, because if I consider the mean value, I will use the blue color. If I consider the mean value, I will erase the coloring. So, this mean value is slowly increasing. So, till about the time unit of 80, it is fixed at a certain rate, and after 80 it increases a little bit and keeps increasing, which means that if I break up this time series into two time zones from 0 to 80 and from 80 to 140, the trend or the average value of the increase from 0 to 80 is less than the value or the trend per unit time. When I am talking about the trend, it means the per unit time of the change of the value which is happening from 80 to 140, which is understandable and we could understand it from the figure. So, let me erase the trend values. Now, comes to the variability, and I will use for the variability I will use the green color. Now, if I consider let me first mark the average with the blue color, because I am using the dots because I do not want to make it cluttered. And this is the increase which has happened. This is just a general trend I am plotting. So, if I find out and draw the variance. So, if you see the variance, it is considering normal distribution as a fit, because normal distribution will give us a good idea of the dispersion both on the right hand side of the mean and the left hand side of the mean, and as it is symmetric it will give us an idea, even though in case of time series generally for the case of financial data, it is not normal, it is basically a class of extreme value distribution. So, if I consider the normal distribution, it continues to be the normal distribution and slowly the variability is increasing, both the mean as well as the variability. Mean we have already seen using the blue line. Now, the variability we are seeing with the green one. So, it is basically exploding, which means that if the time series models are to be utilized and we consider that the time frame from 0 to 80, maybe we can ignore the variability and only concentrate on the first moment, considering the variability change is not that much. But if we consider the second time unit from 80 to 140, there we will see both the mean value, which is the first moment as well as the variability, which is the second moment, are increasing. Hence, time series analysis has to be done in a proper way to understand it. This is just a snapshot of the actual data. Now, this is a second time series, and this is the data related to the yearly net cargo in 1000 tons through Suez Canal. If you remember, in forecasting we have considered the number of vessels moving through the Suez Canal per unit time. Here we are taking the yearly net cargo in 1000 tons. Now, rather than considering the concept of variability, let us consider here the concept of the first moment, which is the trend. So, I will use the orange line. So, if you see from 1975, by the way, along the x axis you have the time frame in years. So, 1975 to about 2015 to 20, and along the y axis we have the yearly net cargo as given here in 1000 tons. So, if I consider, say for example, from 1975 till about 2000, for these 25 years there is an increase in the trend, which you can understand, but the increase in the trend is steady and increasing at a fixed rate. Starting 2000, if I consider the value, and I use a different color here, consider I am using this value of the average increases substantially, which means the trend value is increasing, and if you are able to find out the data fluctuation per rather than year, if you have the month, maybe the data would give us a lot of information about the variability also, because if you remember, when I started showing the data, I said that it is more to understand how the trend is changing rather than the variability. So, if I have the monthly data, it can give us a huge amount of information about the variability also. So, here both mean value and the variability are changing. This is the third example, and we had I mentioned that when we are doing the forecasting model. This is the India's military expenditure in US dollars in millions, 10 to the power 6 USD from 1956 to 2020. So, along the x axis, as it was done for the last example also, example number 37. Here 38 also we are measuring the time frame, and it is given in years. And along the y axis we have the values of the Indian military expenditure in million US dollars. Now, again let us check and utilize two different colors to understand the trend. First, let me use the green one. So, if I consider 1956 to say for example, about 1990 middle year, just post 1990-91, you see there is a steady increase in the Indian military expenditure and it is happening at a constant rate throughout the years. But if I consider the value of the military expenditure starting about 1990 and it goes on till 2020, you see there is quite a substantial increase in the average value. Now, as in example 37 and also in example 38, we are able to definitely give a sure answer or sure direction that the value of the trend is increasing, but if we have the monthly, say for example, if it was available for the Suez Canal problem, definitely data can be available for yearly or weekly amount and monthly amount of data of the total number of cargoes which is passing through. Maybe if we had data about the expenditure on a monthly basis, then the idea of the variability would also be very much stark in the case of example number 38. Now, as I have been mentioning, when we have the zero mean models for time series, it means there is no trend. That means, the trend or the rate of change of the value with respect to time is 0, and the concept of seasonal component would also not be considered. Now, in the concept of the seasonal trend, if you see and if you have noticed in the examples we have considered, there the idea of say for example, the 4 seasons would be coming into the picture to give us an idea how the trend fluctuation happens. It is nothing to do with the variability. Variability would be basically there is a seasonal trend, but is exploding. That means, the variability of the seasonal trend or the gap between the changes which is happening slowly increases with respect to time. So, examples of zero mean models would be the IID noise, where we will consider that given the where the zero trend is, the joint distribution which we want to find out for the probability of x 1 being less than small x 1, which is realized value, would all be independent such that we can only multiply the values of the distribution function individually of the univariate cases. So, f which is given here is basically the function of the cumulative distribution function, and very simple example can be a random walk, that is a man or a woman walking either right or left along a straight line, depending on the probability of moving forward and backward. You will basically utilize this concept in order to find out where the change or where you can model it in a theoretical sense, how the trend can be done. Models for trend with seasonality can be, as I mentioned, sales of fridge, winter garments, they may be, say for example, for coolers, maybe if I am considering the concept of sales of gold in India, depending on the seasons of different type of festivals which you have, I can definitely basically consider the seasonality effect to be there. With this, I will end this 51st lecture and continue more discussion about the time series concept with examples and utilization of very simple models and the calculation to give how time series model can be utilized. Thank you very much and have a nice day.